Hello everyone, welcome to Jee Mains 2013 Physics Solutions. In an LCR circuit as shown below, both the switches are open initially. Now the switch S1 is closed and S2 is kept open. Which of the following statements is correct? Q is the charge on the capacitor and tau equal to RC is the capacitive time constant. When the switch S1 is closed, the capacitor is connected to the battery through the resistor. So the charge on the capacitor Q equal to Q naught of 1 minus e power minus t by RC. At t equal to 2 tau, that is 2 RC, Q equal to CV of 1 minus e power minus 2 RC by RC, that is Q equal to CV of 1 minus e power minus 2. So the correct option is B. A diode detector is used to detect an amplitude modulated wave of 60% modulation by using a condenser of capacity 250 picofarad in parallel with a load resistance of 100 kilo ohm. Find the maximum modulated frequency which could be detected by it. Cutoff frequency of the circuit Fc equal to 1 by 2 pi Rc, which comes out to be 6.37 kHz. Modulation factor root of 1 minus m square by m, that is root of 1 minus 0.6 whole square by 0.6, which comes out to be 4 by 3. Maximum frequency that can be detected is less than modulation factor into Fc. So Fmax is less than 4 by 3 into 6.37, that comes out to be 8.49 kHz. So the correct option is C. The supply voltage to a room is 120 volt. The resistance of the lead wires is 6 ohm. A 60 watt bulb is already switched on. What is the decrease of voltage across the bulb when a 240 watt heater is switched on in parallel to the bulb? Resistance of the bulb Rb equal to V square by P, that is 240 ohm. Resistance of the heater RH equal to V square by P, that comes out to be 60 ohm. Initial voltage across the bulb V1 equal to R bulb by R bulb plus 6 into V, that is 117.07 volt, as initially bulb and the 6 ohm resistor are connected in series. Effective resistance of the bulb and the heater in parallel are equal to 240 into 60 by 240 plus 60, which comes out to be 48 ohm. Now the final voltage across the bulb V2 equal to R by R plus 6 into V, that is 48 by 54 into 120, which comes out to be 106.67 volt. So the decrease in voltage is 117.07 minus 106.67, which is 10.4 volt. A uniform cylinder of length L and mass m with cross-sectional area A is suspended with its length vertical from a fixed point by a massless spring such that it is half submerged in a liquid of density sigma at equilibrium position. The extension x0 of the spring when it is in equilibrium is equilibrium condition gravitational force minus buoyancy force minus spring force equal to 0. So that is mg minus v1 sigma g minus kx naught equal to 0. That is mg equal to a into L by 2 sigma g plus kx naught, from where we get x naught equal to mg by k times 1 minus L a sigma by 2m. Two charges each equal to q are kept at x equal to minus a and x equal to a on the x-axis. A particle of mass m and charge q naught equal to q by 2 is placed at the origin. If a charge q naught is given a small displacement y very much less than a along y-axis, the net force acting on the particle is proportional to force between the particles F equal to k times q1 q2 by r square, that is k times q into q by 2 by root of a square plus y square whole square. Horizontal component of this force cancels each other while vertical components will be adding. So the resultant force F dash equal to 2F cos theta, that is 2 times k into q by 2 by root of a square plus y square whole square into y by root of a square plus y square. Upon simplification it comes out to be k times q square y by a square, from where we have F dash is proportional to y. A beam of unpolarized light of intensity I0 is passed through a Polaroid A and then through another Polaroid B, which is oriented so that the principal plane makes an angle 45 degrees relative to that of A. The intensity of the emergent light is intensity of unpolarized light I0. Intensity of light emerging from Polaroid A, IA equal to I0 by 2, because polarization reduces the intensity of light by 50% theoretically. Intensity of light emerging from Polaroid B, we apply Malus Theorem, IB equal to IA cos square phi. So it is I0 by 2 cos square 45, which is I0 by 4. The anode voltage of a photocell is kept fixed. The wavelength lambda of the light falling on the cathode is gradually changed. The plate current I of the photocell varies as follows. Given the anode voltage of the photocell is kept fixed, as the wavelength of the light falling on the cathode increases, the energy of the photons decreases. Einstein's photoelectric equation E equal to phi plus k max. With a decrease in E, k max also decreases. As kinetic energy of ejected photoelectrons decreases, the number of electrons reaching the anode also decreases. Thus the plate current decreases and reaches 0 when the wavelength goes above threshold wavelength lambda naught. So the correct option is C. Two coherent point sources S1 and S2 are separated by a small distance d as shown. The fringes obtained on the screen will be: path difference between the two rays is S1p minus S2p, the locus of all points on the screen where this path difference remains same is a circle. The circle is symmetric with respect to center O. So the points corresponding to the same path difference will have same intensity on the screen. So there will be alternate bright and dark fringes on the screen in the form of concentric circles. A metal rod of length L is tied to a string of length 2L and made to rotate with angular speed omega on a horizontal table with one end of the string fixed. If there is a vertical magnetic field B in the region, the EMF induced across the ends of the rod is. Consider a length element dx at a distance x from O. EMF induced in the elemental length dE equal to B omega x dx from motional EMF. So E equal to integral dE, that is integral 2L to 3L B dx omega, that is B omega integral 2L to 3L x dx. Upon simplification, it comes out to be B omega by 2 5L square. So the correct option is C. In a hydrogen-like atom, electron makes a transition from an energy level with quantum number n to another with quantum number n minus 1. If n is very much greater than 1, the frequency of radiation emitted is proportional to. Applying Rydberg formula, 1 by lambda equal to R of 1 by n initial square minus 1 by n final square. From there, F equal to RC times 1 by n initial square minus 1 by n final square. So F is proportional to 1 by n initial square minus 1 by n final square. Substituting the given values, we have F is proportional to 2n minus 1 by n square of n minus 1 whole square, that is 2n minus 1 by n power 4 of 1 minus 1 by n whole square. Since n is very much greater than 1, we have F is proportional to 1 by n cube. Assume that a drop of liquid evaporates by decrease in its surface energy so that its temperature remains unchanged. What should be the minimum radius of the drop for this to be possible? The surface tension is T, density of liquid is ρ, and L is the latent heat of vaporization. Let the decrease in radius be delta R. Work done in decreasing the radius W equal to surface tension into delta A, that is T into 4 pi r square minus 4 pi into r minus delta r whole square, which is 4 pi t times r square minus r minus delta r whole square. So W equal to 4 pi t times, simplifying the value of r square minus r minus delta r whole square, we have 4 pi t times 2r into delta r. Energy required to evaporate the liquid drop Q equal to ml, that is 4 pi square delta r into rho L. So from conservation of energy, we have 4 pi t 2r delta r equal to 4 pi r square delta r rho L, which gives us radius to be 2t by rho L. The graph between the angle of deviation and angle of incidence for triangular prism is represented by angle of deviation delta equal to delta 1 plus delta 2, that is I minus R1 plus E minus R2, that is I plus E minus of R1 plus R2, which is I plus E minus A, where A is angle of prism. Applying Snell's law, sin E equal to mu sin R2, that is mu sin A minus R1. Applying Snell's law at the first surface, that is surface AB, sin I equal to mu times sin R1. From there we have R1 equal to sin inverse sin I by mu. So the angle of emergence E equal to sin inverse mu sin of A minus sin inverse sin I by mu. So delta equal to I minus A plus sin inverse of mu sin of A minus sin inverse sin I by mu. Here we got the relation between angle of deviation and angle of incidence I. So the correct graph is 2. Let epsilon naught denote the dimensional formula of permittivity of vacuum. If m is mass, L is length and T is time and A is electric current, then we can use force between two point charges formula for this purpose. F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. From there epsilon naught equal to Q1 Q2 by 4 pi F R square. Write the dimensional formulas of charge, force and distance. We have epsilon naught is m power minus 1, L power minus 3, T power 4, A square. The PV diagram represents the thermodynamic cycle of an engine operating with an ideal monoatomic gas. The amount of heat extracted from the source in a single cycle is. Heat is extracted from the source in dA and AB. AD is isochoric process, so dq equal to ncv dt, that is n into 3 by 2 r into dt. dq equal to 3 by 2 r delta pv by r, that is 3 by 2 r p naught v naught by r, which comes out to be 3 by 2 p naught v naught. AB is isobaric process, dq equal to ncp dt, that is n into 5 by 2 r into dt. So we have dq equal to 5 by 2 r times p delta v by r, that is 5 by 2 r times 2 times p naught v naught by r, which comes out to be 5 times p naught v naught. So the total heat extracted is 3 by 2 p naught v naught plus 5 p naught v naught, which is 13 by 2 p naught v naught. A sonometer wire of length 1.5 meter is made up of steel. The tension in it produces an elastic strain of 1%. What is the fundamental frequency of steel? Density and elasticity are 7.7 into 10 power 3 kg per meter cube and 2.2 into 10 power 11 Newton per meter square respectively. Fundamental frequency of sonometer wire F equal to 1 by 2L root T by mu. So it is 1 by 2L root of T by A into rho, where A is cross sectional area and rho is density. That can also be written as 1 by 2L stress by density, that is 1 by 2L root of stress can be written as Young's modulus into strain. F equal to 1 by 2L root of Young's modulus into strain by density. Upon substituting the values, we have 178.2 Hz. Statement 1. Higher the range, greater is the resistance of ammeter. Statement 2. To increase the range of ammeter, additional shunt needs to be used across it. In order to convert a galvanometer into an ammeter, low resistance is to be connected in parallel. The value of resistance to be connected, known as shunt, equal to Ig into G by I minus Ig. So, in order to increase the range of ammeter, its resistance should be reduced. So, statement 1 is false and statement 2 is true. What is the minimum energy required to launch a satellite of mass m from the surface of a planet of mass capital M and radius capital R into a circular orbit of altitude 2r? Total energy of the satellite on the surface of the planet E initial equal to minus G capital M small m by R plus K initial. Total energy of the satellite in the circular orbit E final equal to minus G capital M small m by 2r, that is minus G capital M small m by 6 times capital R. Applying conservation of mechanical energy, E initial equal to E final, that is minus GMM by R plus K initial equal to minus GMM by 6R. Upon simplification, we get initial kinetic energy as 5 times GMM by 6R. A projectile is given an initial velocity I cap plus 2j cap meter per second, where I cap is along the ground and j cap is along the vertical. If g equal to 10 meter per second square, the equation of the trajectory is angle of projection tan theta equal to Vy by Vx, that is 2 by 1, that is 2. Range of the projectile r equal to 2 by g times u cos theta into u sin theta, that is r equal to 0.4 meter. Equation of the trajectory y equal to x tan theta times 1 minus x by r. Put the calculated values, we get y equal to 2x minus 5x square. Two capacitors C1 and C2 are charged to 120 volt and 200 volt respectively. It is found that by connecting them together, the potential on each one can be made 0. Then, charge on the first capacitor Q1 equal to 120 C1. Charge on the second capacitor Q2 equal to 200 C2. The capacitors are connected as shown in figure. So, the common potential Vcom equal to Q1 minus Q2 by C1 plus C2, that is 120 C1 minus 200 C2 by C1 plus C2. Given Vcom equal to 0, from which we get the relation between C1 and C2 to be 3C1 equal to 5C2. A hoop of radius r and mass m rotating with an angular velocity omega naught is placed on a rough horizontal surface. The initial velocity of the center of the hoop is 0. What will be the velocity of the center of the hoop when it ceases to slip? Initial angular momentum L initial equal to I omega, that is mr square omega naught. Final angular momentum L final equal to mvr plus mr square omega, where v is linear velocity of center of mass, omega is angular velocity when the wheel attains pure rolling. Condition for pure rolling v equal to r omega. Applying conservation of angular momentum L initial equal to L final, that is mr square omega naught equal to mvr plus mr square omega, which gives us v equal to omega naught r by 2. An ideal gas enclosed in a vertical cylindrical container supports a freely moving piston of mass m. The piston and cylinder have equal cross-sectional area A. When the piston is in equilibrium, the volume of the gas is V0 and pressure is P0. The piston is slightly displaced from equilibrium position and released. Assuming that the system is completely isolated from its surroundings, the piston executes a simple harmonic motion with a frequency of. As the system is completely isolated from the surroundings, the process is adiabatic. So PV power gamma equal to constant. Differentiating it, we get a P gamma dV plus VdP equal to 0, from which dP equal to minus P gamma dV by V, that is minus P gamma by V into AX. Restoring force F equal to dP into A, that is minus P gamma by V A square X. Acceleration of the piston A equal to F by M, that is minus P gamma by MV A square X. Acceleration of the simple harmonic oscillator A equal to minus omega square x. Comparing the two expressions, we have minus omega square x equal to minus P gamma by MV into A square, from which we get omega equal to root of P gamma by MV into A square, from which frequency equal to 1 by 2 pi root of P gamma by MV into A square. A charge Q is uniformly distributed over a long rod AB of length L as shown in figure. The electric potential at a point O lying at a distance L from one end A is. Consider an elemental length dx of the charged rod at a distance x from the point of consideration. Elemental charge dq equal to lambda dx, that is q by L dx. Potential due to elemental charge dV equal to 1 by 4 pi epsilon naught dq by x, that is 1 by 4 pi epsilon naught q by L by x into dx. So the total potential V equal to integral dV q by 4 pi epsilon naught L integral L to 2L 1 by x dx, which comes out to be q by 4 pi epsilon naught L ln 2. A circular loop of radius 0.3 centimeter lies parallel to a much bigger circular loop of radius 20 centimeter. The center of the smaller loop is on the axis of the bigger loop. The distance between their centers is 15 centimeter. If a current of 2 amperes flows through the bigger loop, then the flux linked with the smaller loop is magnetic field created by the bigger loop B equal to mu naught I r square by 2 times r square plus x square whole power 3 by 2. Flux of this magnetic field through the smaller loop phi equal to B into area, that is B into pi r square. So it is mu naught I r square by 2 times r square plus x square whole power 3 by 2 into pi r square. Putting the numerical values, we have phi equal to 9.1 into 10 power minus 11 Weber. If a piece of metal is heated to temperature theta and then allowed to cool in room which is at theta naught, the graph between temperature of the metal and the time t will be close to. Applying Newton's law of cooling, d theta by dt equal to minus b times theta minus theta naught. That is d theta by theta minus theta naught equal to minus b dt. Applying integration, integral 1 by theta minus theta naught d theta equal to minus b times integral dt, from which we have ln theta minus theta naught equal to minus bt, theta minus theta naught equal to e power minus bt. So theta equal to theta naught plus e power minus bt. So the correct graph is 2. The IV characteristics of an LED is, here LED stands for light emitting diode. LED is a special diode with a higher doping concentration as compared to normal PN junction diode. Under forward bias conditions, the whole electron recombination energy is high, that lies in visible region. Depending on the materials used for making the diode, LED emits different colors of light. So option 4 is correct, which represents the forward bias characteristics of a diode. A point mass m is moving with speed v collides with a stationary point mass of mass capital M. If the maximum energy loss possible is given as f of half mv square, then f equal to m by m plus m. Maximum energy loss occurs when the particles get stuck together as a result of the collision. Maximum loss of energy takes place in a perfectly inelastic collision, that is, the particles stick together after collision. So statement 2 is correct. Initial kinetic energy of the system half mv square, conservation of linear momentum, mv equal to m plus m of v. So capital V equal to mv by m plus m. Final kinetic energy of the system half of m plus m into capital V square, which comes out to be half mv square of small m by capital M plus small m. So the loss of kinetic energy k initial minus k final, half mv square minus half mv square of m by m plus m, which ultimately comes out to be half mv square of capital M by capital M plus small m. So statement 1 is false. So the correct option is C. The amplitude of a damped oscillator decreases to 0.9 times its original magnitude in 5 seconds. In another 10 seconds, it will decrease to alpha times its original magnitude, where alpha is. Amplitude of damped oscillator A equal to A naught e power minus bt. Amplitude after 5 seconds 0.9 A naught equal to A naught e power minus 5b, from which e power minus 5b equal to 0.9. Amplitude after 15 seconds alpha A naught equal to A naught e power minus 15b, from which alpha equal to e power minus 15b, that is e power minus 5b whole cube, that is 0.9 whole cube, 0.729. Diameter of a plano convex lens is 6 cm and thickness at the center is 3 mm. If the speed of light in material of the lens is 2 into 10 power 8 meter per second, the focal length of the lens is. From the diagram, we can write r square equal to d square plus r minus t whole square, where d is half of the radius of the lens. So r square minus d square equal to r square of 1 minus t by r whole square, from which we get r equal to d square by 2t, that is 15 centimeter. Refractive index of the material mu equal to c by v, that is 3 into 10 power 8 by 2 into 10 power 8, that is 1.5. Applying lens maker's formula 1 by f equal to mu minus 1 of 1 by r1 minus 1 by r2, from where 1 by f equal to 1.5 minus 1 of 1 by 15 minus 1 by infinity. from where we have F equal to 30 centimeter. The magnetic field in a traveling electromagnetic wave has a peak value of 20 nanotesla. The peak value of the electric field strength is peak value of magnetic field B naught equal to 20 into 10 power minus 9 Tesla. Relation between electric and magnetic fields in an electromagnetic wave. C equal to E naught by B naught, from where E naught equal to CB naught, that is 3 into 10 power 8 into 20 into 10 power minus 9, that is 6 volt per meter. Two short bar magnets of length 1 centimeter each have magnetic moments 1.2 ampere meter square and 1 ampere meter square respectively. They are placed on a horizontal table parallel to each other with their north poles pointing towards south. They have a common magnetic equator and are separated by a distance 20 centimeter. The value of the resultant horizontal magnetic induction at the midpoint of the line joining their centers is close to. Horizontal component of Earth's magnetic induction is 3.6 into 10 power minus 5 Weber per meter square. Resultant magnetic field B equal to BH plus B1 plus B2, that is B equal to BH plus mu naught by 4 pi m1 by d cube plus mu naught by 4 pi m2 by d cube, that is BH plus mu naught by 4 pi d cube of m1 plus m2. In the numerical values, we get B equal to 2.56 into 10 power minus 4 Weber per meter square.